Today on Telecom Careers Insiders, we're going to be taking a look at the inside trends driving the demand for RF engineers. But first, a few words from our sponsors, Nexius and Telecom Careers.
Nexius, accelerating network and business transformation.
Telecom Careers, the #1 global telecom and wireless job board. TelecomCareers.com.
Welcome back to another episode of Telecom Careers Insider. By the way, we changed the name from Inside Telecom Careers to Telecom Careers Insider. I'm your host, Jeff Mucci, broadcasting live from the Computer Museum here in Mountain View, California, where RCR Wireless News is covering the Telecom Council of Silicon Valley's TC3 annual event. I encourage you to check out some of the interviews we have on our website. We've got exclusive interviews with the venture arms of SK Telecom, Nokia Growth Partners, Sprint. We also had a great interview yesterday with Amdocs Head of Innovation. We've got several CEO one-on-one interviews, so check it out. It's a great facility, great event going on here in Silicon Valley. Today's topic is RF engineering. When I looked at Indeed yesterday, Indeed has over 5,300 RF engineer-related jobs open on their website, covering everything from RF design engineer at C Spire, which is a regional carrier, to an RF analog system engineer at NXP, which NXP just recently bought a Freescale. And then there's a hardware test and validation engineer at consumer hardware in the consumer hardware division at Google. So here to help us sort out the different types of opportunities within the RF engineering field, we have Ben Wilmhoff, who is founder and president of Blue Flux, based in Louisville, Colorado. Ben, thanks for joining us today.
Good morning, Jeff. Thank you. It's nice to be here.
Well, I think I botched your name there. So how do you pronounce your last name?
No problem. It's Wilmhoff.
Okay, good. Well, Ben, we usually open the show with a rundown of recent workforce-related news. Today, however, I want to talk about an emerging trend that I believe will soon be more prevalent in the news. And more importantly, it's a trend that speaks directly to our topic today, RF engineering. And the trend is really about RF interference. And I want to give you some context and give our viewers some context about why this is impacting me as a consumer. Well, first of all, RCR Wireless, we're going to be doing a review of this Verizon Jetpack hotspot. And when I got a press release on this a couple weeks ago, I immediately said, yeah, please send me one, because it's a Netgear device, and they talked about being a dual band 802.11 AC device. So I'm going to come back to this in just a minute. But the short version is, when I opened it up yesterday here at the Computer Museum, we were hoping to be uploading video. And lo and behold, I tuned into the 2.4 gigahertz channel and did a quick speed test, and the speed download was 10 megabits per second, and the upload was like 12 megabits per second. And this is a dual band 802.11 AC device. It's LT advanced compatible. So I was really expecting speeds of 130, 140 megabits per second, and was frankly surprised. But it does speak to some of my, I guess, other experience recently with RF interference, and why I think this is a trend that people are going to be much more aware about going forward. So another example, yesterday we were setting up to videotape our main stage presentations here at this event, and guess what? Our $900 wireless microphones were experiencing so much interference we couldn't use them. So we had to scramble to get a cable and plug it into our camera, and we experienced that on our other stage. But when it really hit home, and what I mean really hit home, is I pay $70 a month at home for Grande Communications gigabit service. And when we first got it, it was fantastic. I was getting speeds on my Wi-Fi network of 700-800 meg down and extraordinary speeds up, and I thought it was the greatest thing since sliced bread. Well, over time, the speed has just degraded. And finally, it got so bad, I called the tech out, and the tech had this little test device, Ben, and what he showed me was all the neighboring hotspots and the Wi-Fi hotspots in my neighborhood, and you could see the interference coming from all the other 2.4 bands that were being used in the area, and we switched over to the 5G, and immediately things improved greatly. And then I go back to the office, where we have Gigapower service in 2 of our suites, again paying $74 a month for gigabit, gigapower type service from AT&T. And over time, we've seen a degradation of service there. And sure enough, while I didn't have the spectrum analyzer to look at which bands were inherently interfering with each other, I suspect it's the same issue. And the tech came out and swapped out the router and the access point, rebooted it up, and he said, Jeff, you really need to be careful about which devices you allow to be on the 5 gigahertz channel and which devices you allow to operate on the 2.4 gigahertz channel. And it became crystal clear to me that the device has to be 802.11 AC enabled to really get the maximum performance out of these new access points. And then your computer. So I've got an older MacBook Air that has 802.11n. It's not AC enabled. So I'm never going to experience the full benefit of some of these new technologies coming out. More specifically, I'm never going to experience the true value of gigabit service. So I'm going to pause for a minute, Ben. And again, thank you for coming. But I would love to get kind of your commentary on this emerging trend of RF interference, and how big a deal do you think it is?
So spectrum is it's more valuable than water and oil. What you're seeing is, you're seeing the impacts of a whole lot of people trying to access a really, really precious resource, and it's not a commodity; it is a resource. Look what happened in 2010 when the FCC auctioned off parts of the 700 megahertz band, and now they're talking about auctioning off parts of the 600 megahertz band for mobile telecommunications. I think the FCC raised something like $13 billion in that original 2010 auction. Spectrum is really, really valuable, and it's really, really important.
Well, to help us understand RF engineering and walk us through your shoes, talk about your career, but first talk about your education.
Oh, okay. So thank you. So I've got a bachelor's degree in electrical engineering and a master's degree in electrical engineering with an emphasis on electromagnetics. After finishing my master's degree at Michigan State, I moved to Colorado for a job in the defense aerospace industry as an antenna and electromagnetic designer for mostly aircraft. It took me about 2.5 years to realize that I'm not a big company guy. Very quickly moved into a role at a much smaller organization, but still in the defense aerospace industry. I was there for 7.5 years before becoming kind of weary of the pace of defense aerospace. In the beginning of 2013, I had the opportunity to build an RF product development group for a small, very well-funded Colorado technology incubator lab. The company was focused on making the mobile experience better for consumers through technology. The group that I built was focused on the mobile experience as it relates to connectivity and signals. In fact, my group ended up getting a patent out of some really interesting technology in that space. But basically, our role was to help people reach further out from a cell tower. And in that role, I built a great team. I put together an awesome lab, an anechoic test facility, which includes mobile device over-the-air testing. And we set out to develop some great technology. And the fun part was working at light speed with an awesome team. And by the way, almost every one of the folks that I hired in that role are here with me now at BluFlux.
Yeah. Well, talk about what was the catalyst for you to start BluFlux? You're based in Louisville. Why'd you pick Louisville, and why'd you start a company?
So BluFlux is actually very closely related to the company that we came from. In the first year as a technology group, we got really, really interested in what was happening in the indoor navigation space. A bunch of companies were talking about mobile device positioning using Wi-Fi signals, magnetic fields, acoustics, cameras, cell tower positioning, and probably some more techniques that I'm forgetting now. Our interest, and by the way, this is still with the company that we were with before BluFlux, our interest was developing a solution for the public safety space. We knew that developing an advanced technology for public safety and even military communities could eventually be scaled to consumer applications. So it's a profitable business, and it's an important problem to solve. So if you fast forward to the end of 2013, that company that I had built this lab for decided to close its operations. But our lab had done some really, really cool stuff. There was a big investment made into our assets, and we put together a business plan into that company's original investor around leveraging our existing personnel and assets as an engineering service business to offset some of the costs of developing this amazing life-saving technology for the first responder.
BluFlux, I'm on your website here, and you talk about it. It's not just about the cellular industry. You mentioned public safety before. You mentioned aviation. How pervasive is RF engineering and the need for testing?
So, as long as we're delivering data and from point A to point B, and we have proliferation of sensors gathering everything from weather to things that make our cities more efficient, to being able to download and have video calls like this on a high-speed train, that, by the way, which is probably one of the most difficult RF engineering challenges there is. As long as we have a demand for that, there's going to be a role for an RF engineer. And in my opinion, RF engineering I think, can be broken down into three critical pieces of a chain. The first is the antenna. The second is the RF front-end module, which includes, amplification, filtering, and switching. And then you've got, the RF signal processing piece, which is down conversion and, media access control and things like that. To me, the ideal RF engineer is a person that can speak those three different parts of that language, while remembering that the purpose of an RF device is to deliver data and an experience to a user.
Got it. And those three areas again were
the antenna, the RF front end, which is amplification, filtering, and switching, and then of course the transceiver module, which converts over-the-air signals to waveforms and eventually bytes and bits, and eventually to a user application or a user interface.
Well, you mentioned anechoic chambers. Talk about what a chamber does and why it's important to have CTIA certification.
So let's put the work that we do here in BluFlux kind of into context.
Yeah.
If you're launching a wireless product, at some point you're selecting a wireless transceiver module. You're doing a board layout. You're designing and integrating antennas. And then you're doing over-the-air testing, FCC testing, and carrier certification.
Mm-hmm.
As the wireless product designer, a few of those tasks require some pretty special skills. For example, the antenna design and layout and matching piece, and then the over-the-air test piece. Over-the-air testing basically means that you are putting a mobile device through the same set of tests, parameters, and conditions that it would see when it's actually talking to a tower. And it's necessary if you're trying to get an IoT or M2M device, or a custom tablet, or a cell phone, any device that talks to a carrier network, for example, is going to have to go through over-the-air testing. Different carriers have different standards and different protocols, but at the end of the day, you've got to be able to subject your device to these tests and maintain some pretty strict standards on performance. The really, really difficult piece for a wireless product designer is knowing what to do when your product doesn't meet those standards. And that's really what differentiates BluFlux as both an antenna company and as both a over-the-air test company.
How many employees do you have today? And maybe walk us through the different types of skill sets each of them have and where they fit into that test process.
Okay, sure. So keep in mind, we've got an engineering services business, and we've got an internal R&D business, which is essentially being funded by our engineering services business. On the engineering service side, we've got six engineers and technicians, and their roles are, electromagnetic design, RF design, and RF, matching, filtering, RF systems design for mobile wireless devices. We've got 2 dedicated test technicians or test engineers who, by the way, are going to be going through the CTIA certification process next week. Very exciting for us. And then on our R&D side, we've got embedded designers, RF systems architects, and RF hardware designers.
So what does a typical day look like for and pick any one of those or a couple of those? What's a typical day look like for an RF engineer?
Okay, so it might make a little bit of sense to talk about a few of the projects that we have going on to kind of put that into context a little bit. Particularly on the engineering services side, we are supporting companies who are doing work in RTLS, so real-time location system technology, and low-power sensing technology using ultra-wideband. We are supporting companies who are building wearable devices. We're supporting companies that are building cellular connected or WLAN connected devices such as Wi-Fi and Bluetooth. One of the big challenges we see is software and app developers who are designing a kind of a device using a lot of off-the-shelf parts, and you go in and you try to make a product really small and really beautiful, and you basically break its performance. So a lot of what we do day to day is helping recover performance that a non-RF guy might cause to his product. A lot of the work we do, we rely on electromagnetic modeling tools and simulation. These days, electromagnetic modeling tools are really, really good. They're really accurate, and we actually rely on them quite a bit for a lot of our initial work. Typical day, one of our engineers could be found doing kind of one of four things: RF and electromagnetic design, overseeing prototype construction, participating in testing and analyzing test data and model data, and then project management and client interface. I believe in giving engineers kind of access to a full spectrum of tasks at an early point in their career.
So how, you mentioned design, how involved prototype design actually, and you mentioned oftentimes the designers and app developers break the performance of the device trying to make something look ergonomically beautiful or usable. How involved are you on the very front end with some of your customers on the original design of prototypes versus post-broken, go back to the drawing board?
Right. So we, some of our really, really exciting and longer term work is going on right now, where we're starting from scratch, helping really, really important clients. All of our clients are important, but obviously some of the bigger clients, have the budget to invest in, starting a design completely from scratch. You may have seen that we supported Google actually in a project called Soli for a low power wearable radar sensor. We literally started from scratch on the RF piece of RF front end hardware, and in about a year, helped them deliver some prototypes, some of which were seen at Google I/O on May 29th.
Got it. And BluFlux recently announced that you created your own patent that improves cell coverage. Can you talk a bit about that patent?
Yeah, it's very exciting. So we've been exposed to, and we've seen a couple of technologies that sort of claim to improve cell phone signal strength, and there is some merit to some of these technologies, but a lot of them kind of fall short in our opinion. They don't really deliver an experience which is noticeable to the user and to the consumer. Our task and our job was to develop and deliver a technology that would measurably and observably improve cell phone signal strength. So how do you do that? You do that by increasing bars. How do you increase bars? You've got to increase the amount of power that's being delivered to the cell phone antenna terminals. As it turns out, there is a dramatic amount of energy that is lost and absorbed by the human head and the human hands. It's not unsafe, but it's an amount of energy that very much perturbs and changes the way that the cell phone operates. So our job, we knew that the low-hanging fruit was going to be eliminate the effect of the head and the hands on the cell phone signal performance. And so we did that by kind of three key pieces. One is an electromagnetic coupling technology. One is a signal routing technology, and one is the third is an external re-radiation antenna that literally changes the place in space where radiation comes from, avoiding the interference to the head and to the hands.
Changing the place.
Yeah, literally changes. It's changing the phase center. It changes the phase center of radiation of the internal cell phone antennas, because otherwise you're losing energy to the head and to the hands, and the antennas themselves are being detuned by the body. The human body looks like a large piece of dielectric. By the way, a piece of dielectric that's very lossy and absorptive because we have water. Water and fat tissue interact with waves. And so we've figured out a way to mitigate that interaction.
So if I lose some weight, will my phone perform better?
actually it might.
Well, yeah, I remember a couple of years ago, Apple rolled out a phone, and there were some complaints about the way it performed.
Yeah.
And had to do some redesign. I know you don't want to talk about anything specific, but effectively, what was happening there?
Yeah, so great example. So that was, by the way, in the antenna world, they call that antenna gate.
Yep.
It was probably one of the first times that it got to be cool and high profile to be an antenna and RF designer. What happened was Apple started using the external band, the metal band around the iPhone, I think 4, 5, and I think the 4 and the 5. Yep. They started using that as a key part of the antenna. And effectively, they were launching signals directly onto that band in a way that made that band very sensitive to being touched and interacted with by the human skin. As it turned out, there was a really, really easy fix for it, which was just put a small little silicon bumper around the band to just get your fingers just slightly away from that band, and that actually fixed the problem. If you look at the antenna architectures in the iPhone 5, they look to be the same from the outside, but they're actually quite a bit different in that they don't drive that metal band directly.
Got it. At the top of the show, I mentioned that if you go to Indeed and type in RF engineer, you're going to see 5,300 RF engineering jobs. What are the key trends that are having the greatest impact on the demand for RF engineers today?
So I think first of all, MIMO is a really important trend. It's kind of it's a niche, it's a niche technology, but it's one of those technologies that is going to seriously impact the amount of spectrum that we have available. Not really the amount of spectrum, but our use of the spectrum in an efficient manner. There are a lot of reference designs out there for radio transceiver modules and everything from Bluetooth to cellular. I kind of mentioned this before. Product designers have the ability to go off the shelf and select a reference design or a reference module, and without a whole lot of hassle, put together a wireless product. Where the problems come in and where the opportunities are for RF guys is being able to help fix the problems that occur when you integrate some of those relatively simple off-the-shelf modules into actual beautiful products. There's an opportunity there. And I think another trend really is the miniaturization of electronics for wearable devices. Small electronics are very, very sensitive to the things that are around them. They're very, very sensitive to power draw. And so an RF engineer who can understand, a product design and aesthetics, but also can work within the bounds and deliver really, really small and power efficient products is a very valuable person.
So, I mean, and my next question was, what specific skills are in the greatest demand? Talk a little bit more about that skill set and where people gain experience around that skill set. Is it something taught in college? Is it something at a technical school? Is it on the job? So go into a little more detail about some of those skill sets that are in the greatest demand.
So first of all, the skills that are in greatest demand. My message to a young engineer who is interested in RF would be to learn as much about the air interface of the technology that you're working with as you can. So if it's cellular, if it's Wi-Fi, even Bluetooth, learn as much about that air interface as you can, because the interaction between the antenna, the RF front end, the transceiver, and then the air interface is really, really critical. And a person that can speak all 3 or 4 of those languages is an extremely valuable person. That's not going to happen overnight. And I'll admit, even in my own career, I chose to go to get a master's degree because I felt like I needed to learn more before I presented myself to the world as an employee. As far as where to get further training and certification, I have to tell you, I'm a huge fan of IEEE publications. They offer a tremendous amount of content, either for free or for a really pretty reasonable price. For the RF person, I think that the most relevant IEEE societies are going to be Microwave Theory and Techniques, Antennas and Propagation, and ComSoc, which is the Communications Society. And I'll tell you, ComSoc does a great job of offering almost every week. They've got a different online course or a free course, everything from the fundamentals of wireless communications to network virtualization in the cloud to indoor positioning techniques. So I think as a young engineer, I would really recommend joining IEEE and staying ahead of those trends.
Got it. And you had a undergrad in electrical engineering, master's in electrical engineering. As you're going through those curriculums, is wireless engineering and RF engineering a core part of electrical engineering, or is it an elective track that you have to say, you know what, I'm going to focus on RF engineering?
You know, that's interesting. It wasn't 15 years ago when I was doing my undergrad and then my master's degree. But there are a handful of institutions across the U.S. that are starting to kind of pick up on the trend of offering wireless telecommunications as a separate track in and of itself. I would say one of the pioneers in this is Virginia Tech. They actually have a specialty telecoms career, and a handful of other schools are really picking up on this. I think it's critical. There are so many aspects. There's so many pieces of a cell. Just take a cell phone, for example, that you almost it would take you a lifetime of different courses and coursework to try to figure these things out. And the fact that some institutions are starting to offer this as a specialty track, I think it's fantastic. I wish I would have had it when I was in college.
Now, you mentioned a few minutes ago that if someone had this tri-speak that included understanding of air interfaces, they would be incredibly valuable. Talk a little bit about just how valuable they might be in terms of real compensation in today's marketplace.
Yeah, so I think, you know.
And by the way, I know none of your employees are watching this, so we're not going to skew your compensation curve, but I am curious how valuable they are.
Yeah, so some of it depends on obviously your level of education and years of experience, et cetera. I think that you know, a person that can speak all three pieces of that design are going to advance substantially faster than, for example, a dedicated embedded designer, a dedicated software designer, or even sort of a dedicated RF hardware designer. Because a person, you know, that understands really from soup to nuts all aspects of RF, you know, over the air communications and then signal processing, that's really a person that, you know, has studied and has been around this stuff maybe for a couple of years, and has probably done a lot of self-teaching. I think it says a lot about their aptitude, and they're compensated for it. There's no doubt. I mean, just as an example, in this area, a person, you know, with all of those skill sets could fairly easily command somewhere in the mid 100s for a salary.
Got it. And when at the top of the show, I talked about an RF engineer at a regional carrier. I talked about an RF hardware and software engineer at NXP, which is a chip company, and then a hardware and software type engineer, RF engineer at Google. How different are those jobs? And because for the outside person, that's an RF engineer, but you're working at a carrier versus a chip company versus Google, which plays in both hardware and software.
Yeah, sure. So I think you know, that is, RF looks to be just like RF to the outsider. Certainly from the chip perspective, you're most likely looking at a person who is dealing a lot with the specifics of the air interface, you know, media access control, probably doing a lot with MIMO, trying to recover the effects of multipath. And honestly, those folks are of the mindset that I can get away with subpar antenna designs and RF front end designs because I can just fix it all in software and in firmware. The other end of the spectrum, we've actually come across some really talented RF hardware folks, even from Google. Google's got some really amazing things going on in terms of, you know, the driverless car, for example. I mean, that has nothing to do, well, something to do with communications, but there's a lot of work in radar going on there. There's a lot of work in millimeter wave. You know, we're talking about frequencies that at one point were pioneering territory are now being used in consumer applications. That's amazing. Millimeter wave spectrum, 70 and 80 gigahertz. These are really exciting frontiers in the RF space.
You mentioned reference designs early on, and so here at the Computer Museum where we're at, and this conference we're attending, several of the CEOs have talked about, you know, reference stacks and just grabbing something off the shelf and using it in embedded design. What is a reference stack, and I mean, what is it? And
Sure.
how do you know which one's good or not good for use in a product design?
Sure. So from in my world, a reference design means that I can take an off-the-shelf radio transceiver module that has already been approved by the FCC, and perhaps even an off-the-shelf antenna design, and basically plug it into an application interface, inject whatever the user interface that I require essentially onto that board, and I can walk away with a product that may not be in its final enclosure, but a small software and app team can basically launch a wireless product using all off-the-shelf reference parts and reference modules. Where it gets to be interesting from an RF perspective is, what happens when you take that reference product and you put it into a different enclosure. You actually need to put it inside a real product, a product that will change the performance of some of those parts and some of those pieces. That's where you talk about, now you've got to do some modifications. You've got to basically optimize and maybe even a redesign. One of the challenges that we see a lot here at our company is starting with an off-the-shelf antenna design that's plugged into a reference transceiver module. As soon as you make a small change to an antenna, even one that would tend to reduce the amount of output power, that could potentially trigger an FCC recertification effort. So it could be very, very expensive. My advice would be to check with an expert if you have any question whether or not your change or modification is going to trigger some further FCC testing.
Well, Ben, we are out of time. I think we've just scratched the surface and really the tip of the iceberg in terms of the whole RF engineering, testing, and design discussion. But we appreciate your time. I know. Thank you for joining us today, and readers, thank you for joining us this week. A couple things to think about. Check out on our website some of the coverage here at the TC3 event. Also coming up on October 14th at the RCR ATX Studio Lounge, we're going to be hosting an industrial IoT panel. This is going to be made up of a senior VP from Silicon Labs. We're going to have one of the leading technology analysts in the country. We're going to have David Loebman, who is VP of Mobile Test from National Instruments. So we're looking for a real exciting panel. And Ben, just as an FYI, that panel is going to really be talking about industrial IoT and some of the design, test, and the ongoing monitoring that's required for industrial IoT implementation. So thanks again for your time. Readers, thanks for joining us this week on Telecom Careers Insider. Have a great day.
Thank you, Jeff.
To reach Jeff Mucci or to suggest a show topic, you can reach him at jmucci@rcrwireless.com. For all telecom-related news and information, please visit rcrwireless.com. To connect with the industry's top talent, please visit telecomcareers.net.